Okay, good evening everyone. My name is Jauna Mamoko. I'm from Effort International and my SID is 103012440002. So for my final project, I made a data set about height, weight, and age within gender. So I made this data set using information from my friends and my father's friends at his office. And so I already got about 50 plus data, and I used that for my final project. So I'll explain my script. First, I input the library. So this library is necessary for the script, so I'll input it. And then I load the data, of course. So I'm using CSV to read the data, and then I input the data address here. So let me run it first. Okay, so we can see it right here. And second step is I will clean the data. So like this. Okay, so why I must clean the data? So I must clean the data because the data, of course, include like empty data, like the letter is like an A like that. So we drop na right here to clean the empty data like that. And after that, I made the summary about each height, weight, and age, mean and median. So let me run it. And then we can see right here the mean median of height and weight and age as well. So you can see it right here. So for example, like for height female, the mean is 163 centimeters, and for male is 170 centimeters. It's like that. You can see it from right here. I think it's pretty clear. And after that, I made a pie chart of gender distribution. So I already make a comment right here to make it clear, and then I'll run it. So okay, you can see it from right here. This pie chart, the blue one is the male and the pink one is female. So we can see it like the male is dominating the data set. I think it's because I took the data from my father's office, which is mostly male because my father is soldier. So data set is mostly male right here. You can see it from the pie chart, so it's really helped us. And after that, I made a histogram for the height distribution. Alright. So we can see from the histogram that the most high the highest bar right here is at interval 165 until 170. So I think it's pretty clear that from this data set, the average height is around that interval, around 165 centimeters until 170 centimeters. And then I made box plot of height by gender. Sorry. So here it is. So as we can see right here, you can see like the line here is the median of height of the female, and right here is the median of male. No height. So right here, so you can see like the median is on around 160, and for male is around 170. Wait, let me check. Yep. And then I think it's pretty clear, so we can continue. So I made a scatter plot about height versus weight. So I think I'll explain pretty clear about this. So by observing the clustering points right here, we can infer that there's a positive correlation. So when the height is getting more and more and more, so like the weight too. So here, actually there are a line right here. I think we can visualize it on our imagination. So we can infer that there's positive correlation from this, and from the scatter plot it's pretty clear that most of the taller people weight more. So for example, like at 170, most of people is at 80 kilograms, and there's one of my friends that his height is more than 190 centimeters, so his weight is around 110. So it's pretty cool. You can see it from this scatter plot. Okay, so but we can see like there are some points that far from far from the main cluster right here. So this one is like the initial case. So the usual case is right here, and the unusual is one that far away from the main cluster. So like that. And after that I made a correlation plot for numerical variables. So right here. So we can call it heat map tool actually. So heat map is visually represents the correlation coefficients between height, weight, age, and as we can see right here, height and weight have a strong correlation. So wait, let me here. So we can see that height and weight has a strong correlation right here, and it indicates a direct relationship. And for height and age, it's minus, so it indicates a perfect negative correlation. So if you remember, on I think I don't remember which week, but for -1 is negative correlation, for 0 there is no correlation, and for 1 is positive correlation. It's like that. You can see it from like here. And for weight and age almost has no correlation. But we must check it. Yep, so it's close to 0. So it almost has no correlation, just like the material that Mr. Putu teach us. And then after that I made a pairs panel for numerical relationship. So this is use Pearson method. So right here, so we can see it from like here, there's a significant relationship between height and weight. So we can see height and weight. Yep, like right here. So we can making further analysis highly relevant, and age has a weak correlation with height and weight. So you can see age has a weak correlation. Yep, it's true. And but shows a diverse distribution which is worth exploring for a population based insights. And after that I made multiple digit plot visualizations here, as we can see like here. So it's actually like the earlier box plot, but right here I made it for each column. So there are height by gender, weight by gender, and age by gender. If I remember, the previous one is for height. So right here I made it for three of them. So wait, okay. So I think it's pretty clear. So okay, I'll just explain. So for height, like the median is around, for female is around, maybe it's 163 or 65, I guess, and for male is almost 170. And for weight, for female mostly at 61 or 62 right here, and for male is around almost 80. And for age, for my data set, there are, the median for female is what, 50 plus. It's almost the same with the male actually. And the last one, I made an additional scatter plot with regression line. So right here, I'll take note for this actually. So the regression line provides a clear visualization of the relationship between height and weight. So you can see like here, so it's pretty clear visualization between height, a height right here, and weight. So it's like a scatter plot but with regression line. So we can see it clearly. So we use it for making predictions and understanding how these variables are related in the data set. So we can see from right here, so height and weight is related to each other, and so like that. So for the conclusion, it's like this analysis reveals a significant gender-based differences in height and weight. So with males generally taller and heavier and exhibiting greater variability compared to females. And a strong positive correlation exists between height and weight, as shown by the scatter plot and the regression line, and also indicating that taller individuals tend to weigh more. So however, age has a weak relationship between both height and weight, so it's like almost no relationship actually. So like if you're still young, you can weigh more than older people, but for older people it can be like that too. So it's not have a relation actually. And the data distribution show normal like patterns for height and diverse spreads for weight and age, so with outliers highlighting unique cases. Overall, the study provides valuable insights into the relationships and distribution of height, weight, and age, with height being a reliable predictor of weight. So the most, related one is height and weight, of course. But with age, there's almost no correlation. It's like that. So I think that's all. Thank you so much. See you.